Hello everyone, I am Shreya Ghosh and Data Science and Business Analytics intern at the Sparks Foundation. Today I will be explaining about my second task, which is task number 6, prediction using decision tree algorithm. The objective of this task is to create a decision tree classifier and predict the right class for newly fitted data. The steps that I will be following are as follows. Step 1, importing the dataset from Excel. Step 2, preparing the dataset. Step 3, training the model. Step 4, testing the model or making predictions. Step 5, visualization of that model. The last and the sixth step is evaluating the model and diagnostics. So let's begin. Step 1, importing the dataset from Excel. Before importing the dataset from Excel, let us first import few libraries that will be very useful during the task. So I'm importing pandas as PD. Then from sklearn.model selection, I'm importing trend test split. From sklearn.tree, I'm importing decision tree classifier. From sklearn, I'm importing tree. And I'm also importing matplotlib as PLT. I'm using the function pd.readcsv to import the dataset that is stored as a CSV file in my system, the computer system. I am storing the dataset in a variable called df. So here is our dataset. We can see that there are various columns in our dataset like ID, sepal length, sepal width, petal width, and species. In order to get the unique data points in the species column, I'm using the function df.species.unique. And as we can see, the unique names are Iris setosa, Iris versicolor, and Iris virginica. I'm storing these names in species. I'm using the function df.shape to get the number of rows and columns of the dataset. We can observe that there are 150 rows and 6 columns in the dataset. We can observe another thing, that is this ID column is of no use to us. So we can drop this ID column. I'm using the function df.drop to drop the ID column. So now our dataset looks something like this without the ID column. Before proceeding to the preparation of the dataset, let us check whether or not our dataset have any missing values or null values. So I'm using the function df.isna.sum. We can observe that there are 0 missing values in each of the columns. Now moving on to the next step, which is step 2, preparing the dataset. In this step, we will first divide the dataset into independent, that is the x variable, and dependent, the y variable. I'm using the function df.iloc.values to store the values of the independent variable into x. The colon over here means that I am considering all the rows of the dataset. 0 to 4 means that I am considering only the 0th, 1st, 2nd, 3rd, and 4th index column of the dataset, that are sepal length, sepal width, petal length, and petal width. I am storing the values in a variable called x. In a similar way, I am storing the values of the species column into the variable y. So now that we have defined our x and y variable, in the next step we will split the dataset into testing and training data. I am using the function train test split and I am taking test size as 0.2. So it means that we are randomly selecting 20% from the 20% of data points from the dataset for testing purpose and the remainder 80% for training purpose. We can see that xtrain by the use of the xtrain shape, that there are 120 rows and 4 columns in the train dataset and 30 rows and 4 columns in the test dataset, xtest dataset that is. And in ytrain dataset there are 120 rows, 1 column, and in ytest dataset there are 30 rows and 1 column. The next step is training the dataset. In this step, we will be training our xtrain and ytrain dataset. So I'm using the function decision tree classifier and criteria equals to entropy. I am storing this value in model. Now model dot fit x train y train. So I'm training our model and storing it into train. Now the fourth step is testing and predicting the model. So for predicting the model, I'm using the function model.predict x test. That is, I'm predicting the values of the y values with respect to the x test data set. This is our predicted y values. Now let us predict with some newly fed data. So let us predict the species with sepal length 4.6 centimeter, sepal width 3.1 centimeter, petal length 1.5 centimeter, and petal width 0.2 centimeter. So model.predict, I am using the values that are given over here. Then print the species of the flower is, and the model has predicted that the species of the flower is Iris setosa. The next step is visualization of the model. This is first I am showing the textual representation of the decision tree. I am using the function tree.export text model. So we can see the decision tree in a textual form. Next, in a graphical for a graphical form, I am using plt.rc params. When I am giving the dimension as 20 by 20. Then using the function tree.plot tree to visualize our decision tree. So as we can see, this is the visualization of the decision tree. The sixth and the final step is evaluating the model and diagnostics. In this step, we will evaluate how accurate our model is. So I'm using the function model.score x test and y test, and we can see that the score of the model is 0.96. The higher the score of the model is and the closer the score of the model is to 1, the more accurate the model is. So as we can see that the score of our model is 0.96, which is pretty close to 1. So we can say that our model is quite accurate. So with that, I come to the end of the task. Thank you.